I'll just take a minute or two, you guys, and just review a little bit about last week. Give me about 10 or 15 minutes here. I know it's been a long period already, and we'll try to get this out of the way here. Okay, so we did all that fancy derivation, and we ended up with this formula here. A equals V squared over R. Remember coming up with that? Yeah. It was a lot of fun. A equals V squared over R, and then there's the other version of it, which is 4 pi squared R all over T squared, right? 4 pi squared R all over T squared. And then we learned, or I reminded you, that if you want to make it into force, what do? There they are right there. You simply put an M in front, right? So it's mv squared over R, which is a very common one, m4 pi squared R over T squared. Okay? And then we did sample question number 1, and I reminded you, or I taught you, I guess, about frequency and period, right? We used V equals 2 pi R over T. Okay, you guys, listen. Visiting time's over. 2 pi R over T, and then we use the formulas here, okay? Let's skip sample number 2. I really should sort of put these in a different order. Oh no, sorry, we're not skipping number 2. Number 2 is the one I want, okay? Vertical circles are a little bit different. We're still going to keep ourselves horizontal here, but you'll notice, horizontal like this, you'll notice that it has the word vertically in it. Okay, so quite often they give you a maximum braking force by telling you how much it can be hung, how much weight can be hung on it before it breaks. So everyone should be on sample number 2 from that little 2-page booklet. Okay, you should have this already filled out. Oh, all right, okay. So in this case here, we've got a string that can withstand up to 7.5 kilograms hung vertically on, and then it breaks. That's the way it says what's the maximum tension allowed in the string. A piece of string 4 meters long is used to whirl a 2 kilogram mass in a horizontal circle faster and faster. You can imagine that if it's 4 meters long, like that's from like me to Braden or even farther, maybe even me all the way back to Hannah there, it's going to be like it's going to be really hard to make that happen, right? Okay, so what is the braking force of the string? Well, what I mean is, how much can you put on here before it breaks? Well, I told you that number, it's 7.5 kilograms. What's the force on the string? Well, it's simply the weight force. So 7.5 times 9.8. My handwriting seems to have gotten worse over the weekend. 7.5 times 9.8. The string will withstand up to 73.5 newtons. Does that make sense? That's for A. That's the braking force of the string. Whether it's vertical or horizontal. If you apply 73.5 newtons of tension to the string, it breaks. You weren't here either. Okay, so that's how we do the braking force. The maximum speed reached before braking. So now that I have the weight force, if I'm swinging it in a horizontal circle, right? This is becoming my centripetal force, right? That maximum force. And the centripetal force is mv squared over r. So 73.5. The mass, now, radius, yeah. Which mass should I use here? mv squared over r.
7.5.
Steve says 7.5. The 73.5 newtons, the maximum tension. It then says how fast is it going when it breaks? Well, it breaks when the string reaches a tension of 73.5, right? So solve for V. Which mass? 7.5 or 2? Why 2?
That's the mass of the actual imaging.
Yeah, that's the one that's actually being flipped around in a circle. This 7.5 we'd use to break the string, or a similar string, I guess, right? So the mass is that. Solve for V. What's the radius? If the string is 4 meters long, what's the radius of the circle?
4 meters.
4 meters. Right? So V is going to be the square root of 73.5 times 4 divided by 2. Calculator in my pocket.
So how do we?
That works.
Can you do the 73.5 times 4 divided by 2 and then square root?
Yep, do the whole thing. Well, it's really, I mean, the 4 divided by 2 is just times by 2, isn't it?
Just do it all.
So I get 12.1. 12.1 meters per second, is that what you got? Now, what's the period of motion at break time? The period is the t. What's the formula that's got t in it? Well, remember, in that circle,
Why do you multiply the top before there?
to get rid of this divide by 4 here, I multiply both sides. This 4 goes up, becomes a multiply up here,
Isolated B.
Oh, I get you.
right? Times by 4,
Okay.
divide by 2. I'm going to use the distance traveled is the circumference. V equals d over t. We've done this before. The distance traveled is 2 pi r. Oh, by the way, big R and little r, same thing. Sometimes I use big R, sometimes I use little r, and I don't really have a reason for it.
How do you multiply?
Solving for t,
What? Oh,
right? We have to find the period. How long does it take is what we're asked to find here. So my 12.1 goes there.
why do 2 formulas one after the other?
This is v bar equals d over t. What's the distance? The distance traveled is the circumference. And the circumference of a circle is 2 pi r. No, that was the equation number 1 on Thursday when we did that magical derivation stuff. Radius is 4. Solve for t. So t is 2 pi 4 all over 12.1.
Why is I get it.
There you go. I might have done something a little bit around here.
Today, as much as I do video.
Alright, so here's the first set of problems. Please note there are a couple of vertical circles in here, like number 12. You cannot do vertical circles yet, Quinn. If it says vertically, it's a question like this one. But there are a couple where it says vertical circles. Number 12 for sure. Number 9 is a vertical circle. So just watch out for them.
We're not supposed to do.
Do not do the vertical circle. I will explain vertical circles tomorrow. Okay? I gotta go ahead and check on something in the multi there, and I'll be back very soon.